Okay, I'm back. And as you can see, this is where we charged the battery to with the Rejuvenator. Then it fell down to this level, then we loaded it on its C20 rate, according to what the military says for this battery right here. And they want 1.8 amperes, and so we're very close to that here. And you can see that we're holding pretty good here. And we've got a pretty flat curve. There's a step, a little step here, and a little step here, but we're holding pretty darn good for a battery that's just using that. So we're going to let it go, and then we'll see the end of this chart. And then we'll form the plates again with the Rejuvenator and see what happens. Okay, so now we're back, and you can see this is where we charged it with Rejuvenator. Then we let the battery rest and fall down. Then we add the loads. And now look, we're sitting right at this voltage. Look at this line. Pretty darn flat from here to here. So when this reaches around 10.8 or 10.5, the load box is going to shut this off, then we're going to watch it recover, and then we're going to charge it again. And I'll be back. Okay, we're approaching the end here, where the load box is going to determine that it's not safe to take the battery down any lower, but you can see what the voltage is. Now on a lead acid, that'd be dead. But this isn't a lead acid, this is a Alum battery. And so we're going to continue out this load on the light and watch how it falls off as soon as the box decides that that's enough. So when it does that and starts to recover, I'll come right back, because otherwise I'll run out of memory on the camera here. So I'll be back. Okay, I'm back. And the load box has determined that the battery, that's all it can do as far as the lead acid goes, and that's a safe level to cut it off, and you can see it rising here. So I'm going to continue this load now with the car light. And I'm going to show you the light. And we're going to watch it here for a minute. So here's where it started to recover, and then I just switched on the car light to take it down even lower than what the safe area is. So you can see it's continuing out here. So it's got a slight curve to it, and then it's going to start to drop off this way with the light. Now the load box held a continuous 1.5 to 3 amps. It varied with the voltage. And I want to make sure everybody understands that. But the light will be more of a constant current load for it. And that's at about 2.5 amps to 3 amps on that filament. Right there, but there you can see the light. And we're just going to run this out and watch what happens, and I'll be back. Okay, this is where we ran it with the load box down to this point, of which we just switched in the light, so this came up and recovered a little bit. But look at this curve, because the light's still on. So, and that's the voltage that it's hanging at right now. So we're going to just run this until it dips down. And this may take a while, so I might be here a while doing this. But I'll show you the light again. And it's connected up right here to the battery, so that's really real power, and there's real heat. And you can see up there, there's the light on the wall. And I'll put my hand there so you can see. that it's really up there. And that it's real power being developed by this Korean War battery. But that's only once. The plates have been differentiated. And I'll explain all this at the end of the video, what you have to do that. So we're going to go by this meter, and you can see what the curve is. It's ever so slightly down here, and it's continuing to run out. So I'll be back. Okay, I'm back. And you can see our curve is right here. And if I zoom out, let's see if I can get out of here. You can see that our curve is going downward normally now. Just like a lead acid battery would do. So again, I'm going to point out to you that there are some tricks to this battery, which I'll go over at the end of this video. And we're at quite a bit of time now. We're starting to fall off now. See, 9 volts, but we can take this down much deeper than what you can a lead acid battery. And I'm going to take it down. So here's the light. And it's up to the battery with these clips. And this is the real true voltage under load right now. And that's about a 3 amp load. So we're doing pretty good here for a battery that's from 1951 to 52 and never been formed. So I'll be back when this finishes dropping off, and then I'll go over the end of the video. I'll go over everything that I'm supposed to go over with you and how we did this. Okay. Now if we're come back and look at this, we can see what the curve actually is here. This battery is pulled down way below normally what you do with a lead acid battery. So I'll just go out and look at how it's going downward. And this is how it's going downward, and somewhere down here is going to go off and go down. But I'm sort of running out of memory, and I kind of wish it would go down faster, but it's not going to go down faster. And nature is strange, and you know, you gotta run out the curve, and I want to take this down way below to the deepest discharge that I can. So I'm just gonna let it do that, and I'm not gonna come back until it's down there. So this may take, I don't know, 2 more hours or 3 more hours, but I'll be back then. Okay, John back here. Now we're at the end of our discharge. You can see I discharged it all the way down to 1.29 volts. And you can see there's no light, and so now I'm going to let it recover. I'm going to disconnect the load. And right away, you can see it spike up here, and it's at 4.28 volts. So now I'm just going to tell it to do 1,000 samples. And you can see what the curve was all the way down. And that's a very deep discharge. Nothing left to run the light. And this is over a period of almost 2.5 hours of total discharge. Okay, so now it's recovering. Now what I'm going to do is start the Rejuvenator. And we're going to put it back. Okay, and so we've started the Rejuvenator, and you can see right away it's coming up. So now we have totally reversed the action. We're going to go backwards now with this. So into a charge mode. So we've taken the material and moved it from one plate to the next plate, and now we're going back. So I'll be back as this goes up. Okay, one other thing I'm going to point out here. If you look very closely, I don't see if you can see this well, all the plates are basically the same color under that discharge. So they're sort of reddish brown. Now the colors that we want coming back are gray and charcoal gray. So we want the lead, we want the lead, the negative plate to be lead color, sort of slate gray, and we want the positive plate to be charcoal gray, lead peroxide. And then we'll just run this curve over again, and then I'll show you the secret to taking this, and I'll show you some tricks with this to get it to do it when a battery is not formed. I'll be back. Okay, this is a good area in the chart. You can see the battery was dead all the way along here, and then the Rejuvenator, it recovered to here, and then see how the Rejuvenator is stair-stepping it up all the way, and then the impedance changes and it falls down and it adds current here, and then it steps it up again, and then it falls down and adds current, and now it's just stepping it upward at the end of the chart here. So it's really important on the charge on how the machine that's doing the charging analyzes the battery, because what you want is you don't want overcurrent and you don't want undercurrent. So if we look at the current, you can see the Rejuvenator stepping it. See if I can get this in the picture here, how it steps it in current. And these are amps, so it knows it's a small battery and is not going to apply much to it till it gets the impedance right where it wants, and then of course it'll taper off and go up on its curve. So once again, you can see how it's step charging it all the way along here. The impedance falls, and see it chopping it right here in this area. That's taking all the sulfation out. So I'll be back. Okay, we're back, and as you can see, it step charged it up, the impedance fell, and then it charged it back up, the impedance fell again, and now it's chopping it all the way along here, and the battery is at 13.0, about 11 volts as it pulses it up. And then the current, of course, is going to change over here, and now you can see that it's at 9 amps or better, or 10 amps. And it's doing this, the reason the Rejuvenator is doing this is to not overheat the cells. So, back to the chart, and this is our virgin Alum battery, and towards the end of this, after we load it the next time, I'm going to show you how to convert these batteries that have never been formed so that they'll be a good Alum battery for you and you won't have any problems with them. I'll be back. Okay, I'm going to interject this in here. I told you this is a virgin battery, and so what I'm doing with this is I'm taking very diluted sulfuric acid, just like a couple ounces to a gallon, because what I want to do is this is one of the tricks. You need to form these plates and cause a differential, because you can see the material's all the same color. So I'll start forming this, and then as I go along you will understand how this is done. I'll be back. Okay, you can see where I have the battery here, and you can see that the voltage is only at 5.4. That's how dilute it is. Now what I'm going to do is I'll come right back. I'm going to mix. I'm going to take this Alum and I'm going to fill the rest of the battery with the Alum and then form it. And I'll be right back. Okay, now I've completed this in the mixture. These balls are going to settle down. They're just floating right now. I've made this mixture of sulfuric acid and Alum, and what I'm going to do is I'm going to form these plates because I need the differential between the plates. Otherwise the Alum's not going to work real well for us, as you saw. Okay, John back. You can see that we started with this battery virgin, and we charged it all this time, and then discharged it in here, and then we boosted it up here a little bit with a charge with a Rejuvenator, and then this is our first curve, and as you can see, then we charged it again, and this is our second curve, and now we've been charging it all this time, and let me expand that out. Okay, so we got a pretty flat curve. So now what we're going to do is we're going to shut the Rejuvenator off, and then we're going to do a load test. So I'll be right back. Alright. Now you can see we shut the Rejuvenator off, and it's going to come down and sit at a plateau here. But remember, the trick to this is getting the plates to differentiate. In other words, you need two different types of lead. You need the black and you need the gray, or the Alum battery is not going to work correctly. Alright, so let's go on with the load, and what we're going to do is pick a 3 amp load on the load box. So we're going to turn it on. It's our voltage, and it's going to hit 3 amps now. And here we go. And we're going to watch the curve after the plates are differentiated. And I'll be back so you can see what the curve's doing. Okay, I just want to point out to you, this is the current that the battery's developing now with this load box on the first button. But look at the curve, and look where it's holding. So, what you want to do with a virgin battery is you want to form the plates with dilute sulfuric acid plus Alum. That's the trick. And then you'll get this sort of curve with an Alum battery. Now remember, this battery, if you take this voltage, divide it by the 6 cells, that's what each cell's standing at. Now some would consider this a dead battery, but it's far from dead, and it has a lot of power. As you've seen in the earlier part of this video, that I can take it down to a ½ volt in the end and not hurt this battery. So we're going to let it go, and then I'll finish up here. Okay, now normally this is a 24 amp hour battery, and the military says they want 1.8 amps, but we're at 3.6, which means that we're at a C7 discharge rate, and we're just going to let it go to the end to where the load box shuts off. But you can see it has some real power now, and it can sustain this energy level for a long period of time at this current. So for those that don't think it's possible, it is possible if you differentiate the plates. And that if you start with a virgin battery that's never been formed, you must form that battery with a mixture of Alum and sulfuric acid to get these colors on the plates. And that would be charcoal black and slate gray. And that's the difference between the positive and the negative plates, this being the positive and this one being the negative. You've got to have this differentiation in the battery, or the chemical won't work right. So we'll let this go. This basically is how that you create an Alum battery from a battery that's virgin. Now a normal automobile storage battery, you can just go ahead and dump out the acid and replace it with Alum. But remember, they stand at a lower voltage. That doesn't mean they don't have any power. So we'll let this continue, and I'll be back when this finishes. And that'll end this video on the conversion of Alum batteries. Okay, we're back, and we're approaching the end of the curve. You can see we're at 10.92. Now normally at 10.50, a lead acid battery, you don't want to take it down below that. But we're going to take this right on out with the light after the load box shuts it off. And so I'm going to set that up in the meantime, because I'm going to run it right out like I did before, just to show you that the power is really in the battery when you do this conversion, and that you're not hurting the battery, because we ran it to a 1/2 volt very early on, and now we're going to do the same thing again and see if we get extended time out of it. And I'll be back. Yeah, here's something really surprising. See, the battery sagged right here for some strange reason. We got that 10 volt reading, but we're far from approaching where the load box is going to shut this off. It went down and then it just rose right up here, and you can see here, nobody's done anything here. And we're still maintaining this current of 3.58 amperes. So you can see this little dip right in here. Something occurred here where the impedance dropped and then came back. And that could be sulfation broke away, and then the plate got exposed and the current came back. And that's very possible, because this battery is sat on the shelf since 1951 to 52. And I'm not at all surprised if there wasn't corrosion on the lead never being formed just from the pasting of the plates. So we're just going to let it run out. I'll be back. Okay, we cut off, and we cut off in here, right here, and then the battery started to rise right there. But I strapped on the light again, because I want to take this down to show you that the power is in the battery, and then that'll end our series here on this battery. Okay. Now I want you to see this discharge. I've pulled this battery down now to 3.89 volts, and I'm going to expand the chart, and then this will be the end of this presentation on this. Okay, so what I've done is I've done all this. This is expanded out, and you can see that I've charged it here and loaded it here, and then charged it and then loaded it all the way down. And then by the differentiating the plates, I started to get more time, and more time. So now if I expand it out, you can see here that it fell off. And this has taken almost 4 hours to do this, to get it down to this level. And so, anyway, guys, that's what you can do with an Alum battery. And I want to go over one other thing here, that it's advisable that if you're doing a virgin battery, that you make the mixture earlier on here, like I showed you, and differentiate the plates, and then put the Alum into the battery. And don't look for any hydrometer reading, because you won't get it. And so with that, I'll just say goodbye, and glad I could bring you this information.